of series discussed in this section is something called a telescoping series. All right, it's a series in which most of the terms cancel in each of the partial sums. So we'll write the partial sums, take a look at what's happening, and so you leave only the first and essentially the last terms, or some of the last terms. So what's happening here? So this is an example. We've got bn minus bn plus 1. So we have the b1, which is going to stay, but then we have a negative b2, and then we have a positive b2. So these two cancel out. And then we have a negative b3 and a positive b3. Those cancel out. And then we have a negative b4 and a positive b4, that those cancel out, and so forth. So each of the sums of each of these, so S1, sum of the first, we have B1 minus B2, we're just plugging in N1, N equals 1, and that's what we get. There's nothing to cancel. In S2, the B2 and the B2 cancel out, so we're left with B1 minus B3. And the S3, B2 cancels with B2, B3 cancels with B3, and we're left with negative B4, so B1 minus B4. And then they give us the general, the kth partial sum. So the sum when n is k, sk, that's this notation here. Sum when when n is k, is equal to b1 minus b subscript k minus 1. Okay, k plus 1, excuse me. K plus 1, not k minus 1. Okay, now since the kth partial sum can be simplified to the difference of these two sums, the sequence of the partial sums, sk, will converge if and only if the sequence bk plus 1 converges. Moreover, if the sequence bk plus 1 converges to some finite number b, then the sequence of partial sums converges to b1 minus b, because eventually we're getting to that whatever b is, big B is at the end. So if it converges, this is what it's going to look like. All right, so I've got an example down here that we're going to do. Evaluate the following telescoping series, or state whether the series diverges. So evaluating it means, what does it come out to be? So, do we get a B1 minus B sort of situation, or does it diverge? So let's start writing a few of the values here. So let's start with S1. So that's going to be 2. N is 1 here, so it's 2 to the 1 over 1 minus 2 to the 1 over 1 plus 1. All right, and that equals just 2 minus 2 to the 1/2 power, or the square root of 2. All right, that's our first one. Let's take a look at S2. Again, we have 2. We have, we're going to have a minus 2 to the 1/2, and then we're going to have, for the next one, that should be a plus in there, 2 to the 1/2 minus 2 to the 1 over 3. So again, these cancel out, and we're left with 2 minus 2 over 1/3. And the next one, S3, will be 2 minus 2 over 1/4. So we're taking the fourth root of it, and so forth. So essentially what we have, we're in a situation where we've got Sn is equal to 2 minus 1 over n, 2 to the 1 over n plus 1. Well, what's happening to 1 over n plus 1 as n gets really, really large? So this part here this goes to 0 as n goes to infinity. As we were taking a limit. So if we've got a fraction with the value in the denominator that's getting bigger and bigger and bigger, the whole fraction goes to 0. So if there's nothing on top getting any bigger anyway. So that means it's going to be 2 minus 2 to the 0 eventually. Let's go back to this. So this equals 2 minus 2 to the 0, which is 2 minus 1, which is just 1. So we can evaluate this telescopic series to be just 1. Again, work is involved. You have to show what's happening, but that's what it comes down to. It will converge and will converge to 1.